Okay, I'm going to go ahead and get started for tonight. I have tried to adjust my screen resolution to make it a little bit easier for people to see what I'm doing. Hopefully, it won't be as blurry this time around. Um, Please feel free to, email me or post a question in the Q&A feature of the Google Hangout if you are noticing problems, and I will try to adjust that further. The one thing to keep in mind, though, is that because I've adjusted my resolution, my screen is smaller now, and so I can't put the Q&A feature to the side so that I can see it as soon as it comes. So it may take me some time before I notice that someone has posted a question. Okay, so I'm going to go ahead and start with doing some more Excel. Basically, it's going to be pretty similar to what we did last week. Um, but I noticed that there were some questions in the lab this week about the count if, as well as some other things. So I did just want to quickly run through some basic Excel examples again, and then I will move on to doing some stuff in SPSS. So I generated some fake data for this week. And I just want to remind, so before I actually start with this, let me just point out that for last week, the exercise that I did is going to look slightly different from the exercise that I posted online. I realized that I should not have had um, two of these tables in the same tab of the spreadsheet, because as you sort the data, as I showed you last week, you sort the data, and as we talked about, it does not update the cells that it's referencing. And so as I sorted by gender and then changed it to sort by something else, what it did was it actually changed all the numbers in here. So you'll see when you open the examples from last week that there are now two tabs down here at the bottom. So in Excel, you have the option of having as many different tabs as you want. And you can just click on different tabs to go from one set of data to another. Now, in the example from last week, it has two tabs with the exact same data, but one table in the first tab and another table in the second tab that will allow you to accurately look at the differences by both gender and the other variable that we looked at last week, which I believe was race ethnicity. Okay, so in this data set, I've created some data that, as you can see across the top, we have an ID number. And again, this is just a reference to each individual person. It can be helpful to have if you ever need to sort back to the original way that the data were. It can also be helpful, further down the road as you get more advanced. You may need to merge more than one data set together and whatnot. So I always assign an ID number to people in my data sets. Then I have gender, and as you can see over here, I've coded gender so that 0 equals male and 1 equals female. I have HIV status, and as you can see over here, I've coded HIV status so that 1 equals negative, 2 equals positive, and 3 equals unknown HIV status. I have borough, and as you can see over here, I've coded borough so that 1 equals Manhattan, 2 equals Brooklyn, 3 equals Queens, 4 equals Bronx, and 5 equals Staten Island. And then I have age, which is, of course, a relatively continuous variable. I have a score on a depression measure, which is also a continuous variable. I have general health, a rating of general health that goes from 0 to 20 and is also continuous. I then have the number of hours that they slept the night before, which is a count variable. And then I have the number of drinks that they had the night before that. And so all of this is intended to be data from a survey that was given, where these are categorical demographic variables. This is a demographic variable that is continuous. Then these are two scales that people would have completed. And these are two fill in the blank questions where someone answered how many hours of sleep they had the night before and how many alcoholic drinks they had the night before. If I scroll down, you can see that we go down to line 250, which means that we have 249 cases of people, which is evident if you just look at the last ID number, which is 10249. Keep in mind that we do have that first row that is the labels for each of the variables, which is why even though we're going down to the 250th row, we only have 249 individuals in the data. Okay, so the first thing that I want to remind you to do is to turn on the variable filtering feature. So again, that's under sort and filter over here. So you want to select the variables that you want to be able to filter by. And then you want to select the filter button. And then again, that allows you to do things like sort smallest to largest, sort largest to smallest. You also see down here that you have this select feature, which doesn't make much sense for the ID, but for example, under gender, we could have it so that it doesn't show all the genders. So we could have it so that it only shows us the ones, which are the females. And so now we have this data set where we don't see every row. We only see the rows where the gender variable is equal to 1. And we could also then go back and select all and then unselect 1. And then that would only show us the rows where the gender variable is 0. So all of this just to say that sorting and displaying a selected amount of rows can be helpful for certain tasks. And so I always turn on this variable filtering feature before I do anything. Okay, so just to give a brief recap of what we did last time, I created a very brief exercise where we'll be looking at the depression score based off of the gender of the participants. And so if you remember from last week, we can do the number of males and the number of females using the count if feature. So in a data set that is this large, 249 people, you certainly don't want to go and count by hand all of the individuals. The other thing you'll notice is that if I do filter out, for example, the males, it will tell me at the bottom how many that I have. But that's not the best way of doing it. And the other thing to notice is that it still shows you down to row 250 because it's showing you the row numbers of who is visible. So for example, it goes from 235 to 240 because all of the cases between those two numbers are actually cases of males in the data set. And so it keeps the row numbers the same, even though there are missing rows in there. Okay, so then all we have to do here, recall, is to start a function, we do equals. And then if we want the count if function, we just type that in. And remember that your menu is going to come up here. You also have the option of clicking this function button up here. And then we type count if, and we open the parentheses. You always have to open the parentheses to do a function in Excel. And then I could either start dragging and select all of the people, but because this is a larger data set, I know and recall from last week that columns are always referenced with a letter and rows are always referenced with a number in Excel. And I know that we go down to row 250 and that, as you can see, the data here start at row 2. And so all I have to do is we're looking at the gender variable. So we want column B, and we know that the data start at row 2. So I want B2. And I want that, I put a colon in there to tell it how far I want it to go. And then I want to stay in column B. And I want it to go all the way down to row 249 or 250, which is the last person in the data. So then I just do B250. And then I do a comma, and then I put in the criteria. And so the criteria in this case is for males, and the males in this data set are coded 0. So we just type in a 0 there. Remember last week we typed in, we put in quotes a word. So we put, for example, quote male or quote female. As you can see this week, because we're about to be working with SPSS, I've chosen to give all the different groups numbered values. And so in this case, then we don't actually need to put quotes around the 0 anymore because Excel recognizes that as a number. And then I'm just going to do the exact same thing. So remember, just recall again that if I want to drag this down one, I'm either going to have to update this range so that it corrects again, because if I drag it down, it's going to change it to B3 to B251, because if you drag down one, it automatically adjusts any series like this to go down one as well. Or what I could have done was put $signs in front of the B2 and the B250, which then tells it do not move down a row when I go down a row. So now in that case, I can actually just drag this down and change the 0 here to be 1, because now we want the females and 1 corresponds to the female value. And you can see that now we have 135 males and 114 females. I also obviously could have just easily typed in here, again, count if B2 to B250, comma 1 without the dollar signs. It doesn't make a difference which you prefer to do. And again, also I could have avoided, if I didn't remember how to reference these rows and columns, I could have again just dragged all the way down. But because this is a longer file, and because I want you to be more familiar with how Excel is referencing these different cells, I went ahead and I used the feature of just typing in those values. Okay. So you'll see me switch every now and then to go back just to make sure that there are no questions being asked. And I know it looks a little funny when I do that because you see a million of my screens going back. But I just wanted to let you know that I am trying to check, every couple of minutes just to make sure that nothing has popped up. Okay, now we want the percent of people that are males and the percent of people that are females. So all we have to do is equals, and then we want the number of males, which we can get right from this cell. And then we want that to divide that by the total number of people. So one easy way of getting the total number of people is to just take the count, not count if, but just the count of all of the ID numbers. And so the ID column is A. So we're going to start at A. And then I'm going to want to move this down into the female row as well. So I am going to use a dollar sign here so that it doesn't change the rows when I move this down. So I'm going to do a dollar sign, and then I want to start at A2. So I do a dollar sign 2, and then my colon tells it where to go, how far to go. And then I'm going to do A again because I still want to stay in column A. I don't want it moving over into any other columns. I want to do a dollar sign because I intend to pull this down into the next row below, and if I don't do the dollar sign, then it will adjust this to be A3 to A251, and I want it to stay A2 to A250. So I'm going to do a dollar sign 250, then comma, or I'm sorry, no comma, because we're just counting the number of cases in the data set. All we want is to know is how many rows are there of ID numbers. And so now we have this 135 that we already calculated divided by the number of rows here from A2 to A250, which we already knew, of course, was 249. But in case we didn't know that, or in case that could change, it's good to use the functions. I'm now going to change this to a percent, as we talked about before. Up here in the number section, we have the option of quickly and easily changing that into a percent. So that'll make it 54%. And then I'm going to drag this down. And so now you see that 54% of our sample are males and 54% of our sample are females. And now we want to know the mean, the median, the 25th percentile, and the 75th percentile for the males and for the females. And now, again, in Excel, the easiest way to do this is to sort by gender. And so I am going to sort smallest to largest. And I am going to then calculate the average that way. So I do equals, and then again, remember that in Excel, it's not called the mean, it's called the average function. And so I do equals average. And then we know that there are 135 males, and we know that what we want to measure here is the mean depression score. So first of all, we know that we want to be in column F, and we know that we want to go for the first 135 rows of that column because that's how many males we have. If I didn't know that, then I could simply just, again, I could select all the way down until the zeros in the male column or in the gender column stop. So as you can see here, this is my last 0, which corresponds to the last male, and the 1 start after that, which corresponds to the females. So we're going down to row 136, which makes perfect sense because we have 135 males and the first one doesn't start until row 2. So we could have also figured that out ourselves, but because we did the drag and drop, Excel figured that out for us. And so then all we have to do is close that parentheses, and it's going to calculate the average depression score for the males going from row 2 to row 136 because we've sorted by gender. And now here, I can easily do equals the average. And I know that I want to be in column F for our depression scores. And I know that we just went to row 136 for the males, so I know that I want this to start on row 137. And how far do I want it to go? I want it to go to the last row because that's where the last female is. And because I sorted by gender, the females go from row 137 to the final row, which is row 250. And so I want column F for the depression score, and then 250 because that's the last row in the data set. And I'll actually scroll down and I'll show you Excel has automatically highlighted these for me just to show me what it is that I'm selecting. So if you're ever not sure that you put it in correctly, you can always go down and look because Excel will have those outlined for you. And you can easily see here that the first female did indeed start on row 137. So this is the first female's depression score. And the last female, as you can see, the last one in this gender variable goes to this last depression score here. And so this is going to be the average for those females. Okay, so what we're seeing here is that on average, our males are responding with somewhat higher depression scores than our females are. And of course, in the future weeks, we'll talk more about how to test whether those are really all that different or not. But for now, just know, of course, that 5.1 is higher than 5.0. And remember, we talked about last week that sometimes we don't want this many decimal places. So I'm actually going to highlight all of the places where we're going to be taking parts of the depression score, or some function of the depression score. And I'm going to use this feature right here, which tells it to go in by 10, decrease decimal, as you see it says when I hover over it. This is the increase decimal. So if we wanted another decimal place, we could hit that. But what we want to do is get rid of a few decimal places. So I'm going to hit this button a couple of times so that what we end up with is just 2 decimal places here. And then because I've selected all of these cells together, it does that for all of the cells. So now automatically when I put anything in here, it's automatically only going to put them to the second decimal place, whereas otherwise it may have carried them out to 4, 5, 6 decimal places. Okay, so then the next thing we want is the median for the males. And so I'm going to do equals median. And then again, we're in column F because we still want to use the depression scores. So I'm going to start with column F, and I want to go from column F in row 2 because that's where the first male is. And as you can see, as soon as I do that, it highlights that cell so that I know that I'm choosing the right one. And then again, remember from last time that we went from row 2 to row 136. So we want to stay in column F. So I start with an F. And then we went to row 136 because we have 135 males and they start on the second row. So 136 will take us to the last male in this data set. And again, let me just scroll down and show you that it's highlighted all of those so you can quickly scroll down and make sure that you got it right, that F136 is the last score for a male. And then I press enter. And then I'm going to do the median for females, which again, we know that we want to stay in column F. So I start with F. We know that the first female starts on row 137. So I type in F137. I put in a colon because that tells it how far I want to go. Again, I want to stay in column F, so I do an F. And then I know that I want to go all the way down to row 250 because that's what the last female is. Then I close that parentheses. Again, let me just scroll down and show you. We can confirm it. The first female does indeed start in row 137 with a depression score of 9. The last female is in row 250 with a depression score of 2. And then we can press enter. And what we see here is that even though the means are slightly different, it actually seems that males and females in this data set have a median that is the same on the depression score. And then the last thing we want to do is use the percentiles function. And so we're going to do equals percentile.inc for inclusive. And then again, we want to be in column F, and we want to be in row 2 for the first male, and we want to go to column F, row 136 for the last male. And then what we need to put in next is our percentile that we want expressed as a decimal point. So in this case, we want the 25th percentile. So that's 0.25, close parentheses, enter. So we get a 4 for that. And then for the females, we want to do the same thing. So percentile.inc. I want to tell it where I want the data to be. So again, we're in column F, row 2, to column F, row 2, or I'm sorry, excuse me, let me go back. I did that incorrectly. For the females, we are in column F, row 137. and they end in column F, row 250. Again, doesn't hurt to go down and check that we did that correctly. So I did get it correct that it starts at row 137, and I did get it correct that it goes down to column 250. And then I press enter. Oh, excuse me. Because we're doing a percentile here, the next thing I need to do is tell it what the percentile is. Just like for the males, what we want is the 25th percentile. And so we go ahead and put 0.25 because that's 25% expressed as a decimal point. And we see, again, that not only are the medians the same for the males and females, but the 25th percentile is the same for the males and females. And then the very last thing that we want to do is the 75th percentile. Now, keep in mind, one thing I could do is just type this all in. So I could do percentile.inc. I want the males, so I want F2 to F136, comma, 0.75, close parentheses, and I get a 6. That's one option, is just to type it all in again. It's not too hard to do. Doesn't take too long. But when you have a lot of things that you're calculating this for, it can be a lot easier to drag those functions over. So what I want to do is make it so that I can drag over this 25th percentile function. In order to do that, the rows are going to stay the same, actually. So we're still going to be in row 2 to row 136 because we're still going to be only looking at the males. But what is going to change is if I try to move this over one column, it's also going to move this function over one column. So it's going to take depression and move this box over into general health so that it's going to take the 75th percentile of this general health variable instead of the 75th percentile of depression. The way to stop it from doing that is to put a $ in front of the columns. So in this case, the columns are F. So I'm going to put $F2 to $F136. And here I'm going to put the same thing, $F137 to $F250. I still want it to go from row 137 to row 250, and I still want it to go from stay in column F. Because I'm not moving this by a row, the rows are not going to be changed by Excel. But I am moving this over into a new column, which means the columns would be changed by Excel. So putting that $ in there stops Excel from changing those columns on you. So then what I can do is just highlight both of these and drag them over into the 75th percentile. And then the only thing I need to edit is this 0.25. So instead of 0.25, excuse me, instead of 0.25 here, I want 0.75. And the same thing for the females. Instead of 0.25 here, I want 0.75. But notice it kept these the exact same. Nothing about this range of cells changed because we put those $ there in front of the comma. Or I'm sorry, in front of the column. Had we not done that, what it would have done is it would have moved it would have moved the box from depression over into general health because we moved this box over into this box. It's always going to move in the same direction that you do. So if we drag something from here over into a row to the left, then it's going to take those columns and go from the row here or the column here to the column to the left. It always goes in the exact same direction and by the exact same amount as you do. So if you copy from one cell down 4 rows, it's also going to take any functions in that cell and move them down by 4 rows. If you copy something from here and go left 3 columns, it's also going to take the function inside of there and go left by 3 columns with it. Okay, and so just like we had with the median and the 25th percentile, the 75th percentile is the same for both males and females. Now, if we wanted to calculate the interquartile range, which is just the 75th percentile minus the 25th percentile, we could simply do equals this cell minus this cell, and then we could pull that down, and then it's automatically, as you can see here, we have Q16 minus P16, and here we have Q17 minus P17. Because we moved it down a row, it also moved the function down a row, and you can see that it even moves the boxes for you so that you can verify all of that. Okay, so that is calculating these things in Excel. Let me just put IQR here so we know what this is. I'll put a box around these. And I'll save this so that I can upload it for you later tonight. All right, so we are going to save that. And the next thing that we are going to do is work in SPSS. So just to give you a brief tutorial, brief intro to the way that SPSS works, we have two different views to start off with. So just like I just showed you that in Excel, you have tabs where each tab can hold different data. In SPSS, each data set is separate. So you can't have tabs of different data, but you can have multiple windows open with different data. But the tabs in SPSS correspond to two different views. So the first view is the data view. And this looks a lot like Excel, except that the variables do not get their own row that counts as an actual data row. They have a special row at the very top so that they don't move. So when you're scrolling, the variables are always there and everything. So in SPSS, unlike in Excel, the first person is always in row one. In Excel, if you want to give variable labels, you need to use up a row, and so the first person always starts on row two. In SPSS, it's a little bit more intuitive. It makes a little bit more sense. The first row is always also the first person. So as many rows as you have is as many people as you have, whereas in Excel, that's not the case. So each person gets a row, or each case of data gets a row. In some cases, each row may not be a person. Each row could be a school, or each row could be one time point for like the same person could have more than one row if they were measured multiple times. So each row is not necessarily a person, but it's a case. And in this data set, all of our cases are individual people. As you go to the left, you see all of the variables, and you scroll down, and you can see that we again have 249 people. So the data view, in some ways, can be thought of as the cases view. What you're viewing here are each of your cases of data, hence why it's called the data view. Now, in contrast to that, the variable view, which again you get to by clicking on the tabs here, or another way to get to the variable view is by clicking on one of the variable names. So if I want to go to the gender variable and look at it, I double click on that, and SPSS automatically switches me into variable view and highlights the variable that I double clicked on. All right, so each of these variables in SPSS has a bunch of different features. So unlike in data view, where each of the columns is a variable, in variable view, each of the variables becomes a row. So you'll have as many rows as there are data, whereas in data view, the columns are data. So each of these has a few different characteristics. The first is the name, so that's giving it, and that is important. You want to name your variables something that can make sense to you. So as you can see, each of these is relatively descriptive in its name, and the name is what is referenced by SPSS anytime that you're using the syntax. You next have something that's called a variable type. In general, what we will be dealing with are all numeric variables, but some of the other types that could be used, for example, are strings or dates. As you get into more complex analyses, sometimes you might have data that include dates in them, or you might have strings where people actually write in a long response, in which case it has to be stored as a string, which basically just means text. But in general, most of the variables that you'll see are going to be numeric variables, even if the number doesn't hold meaning. So again, remember that, for example, gender, the ones and the zeros don't hold any numerical meaning. For example, the females are ones and the males are zero. It doesn't mean males have zero of something and females have one of something. All that it means is that we are using a number to take a placeholder for something that has meaning to us. All the variables have a width, which just means how many characters wide the variable can become. So what this means is that, for example, the ID number cannot be any wider than 12 numbers. So we could not have a 15-digit ID number in this variable. We would need to increase the width in order to allow that. We also have this decimal. So right now we have no decimal places for any of our variables. But if we wanted to allow decimal places for our variables, we could increase that decimal column. We have labels, which I'm going to show you in just a minute how to make for our variables. Actually, let me go ahead and do labels now, and then I'll go continue going right with each of these, and we'll do them for each. So the labels are where you can put in some much longer and more descriptive information about what exactly the variable is. The variable names should be kept short. I forget what SPSS's most recent version's limit is for how many characters can be in a variable name, but they're not unlimited. There used to be a time when they were limited to about 8 characters only. Now they can be much longer than that, but they do still have a limit. And so the label is the place where you could write a sentence, you could write a question, you could put a bunch of text in there. You can really be as descriptive as you want. And so what we're going to do here is just type in some labels for each of these variables. So the ID variable is pretty self-explanatory, but I'm just going to put in here participant ID number. You can see here that I can include spaces here. I can also include some special characters like a dash or a question mark. So these are places where you can actually include characters that sometimes you can't even include in the variable name. So gender, I'm going to put here participants gender. But I could also put this, just to show you that you can make this into a question or really whatever you want. I could also put here, is the participant male or female? So that would be another option there. For HIV status, sometimes what you want is details on how exactly the data were obtained. So for example, with HIV status, we could have given participants an HIV test, in which case we might want to type in here result of HIV tests. In this case, I'm going to say that we did not give them a test, that we allowed them to tell us their HIV status. So then in this case, it's important that we know and put in the variable label that this is self-reported HIV status. Sometimes this jumps around when you're typing. The next thing is the borough. So I'm going to just type in here New York City borough of residence. Age, I'm just going to put participants age. For depression, so if we had used a specific scale, so for example, the Beck depression inventory, then we would want to put, we don't have to, you can do whatever you want, but we might want to put Beck depression inventory score. Here instead, I'm going to put depression score, and then I'm going to actually put in here what the range of values could be. So in this case, the depression score can range from 0 to 10. Again, this is just showing that you can put anything you want in here, including things like parentheses. So in this case, I'll put depression score 0 to 10. For general health, again, similar to HIV status, it's important to know how are we getting this? Are we getting this from some sort of medical record? In this case, what we did is we administered them a scale about their general health, and they told us how healthy they felt on a range of different items. And so I'm going to put here self-reported general health status. And I'm also going to put here 0 to 20, just so we can keep in mind that for this scale, they could have had a score ranging from 0 to 20. Sleep. So this, sleep, the variable name is somewhat intuitive. But for example, if you're doing a study that's all about sleep, a variable named sleep is not going to really help you out very much. If you have more than one variable that has to do with the topic, you need to be a little bit more descriptive, especially in your variable label. So here what I'm going to put is how many hours did the participant sleep the night before the survey was taken? So that's a very long one. You can see that it lets you go pretty long there. And then drinks, I'm going to put how many alcoholic drinks did the participant have the night before the survey was taken? Okay, so now all of our variables have labels. And then I just want to show you some of the reasons that you would want to put in a label. The first one is that if you're in data view, you can hover over a variable to find out more about it. So for example, if I hover over HIV status, it tells me that it's self-reported HIV. If I hover over borough, it tells me it's New York City borough of residence. Participants age, depression score 0 to 10, self-reported general health status 0 to 20. So that can be very helpful when you're when you're going through here, say I find something really weird about one of the participants' scores, I want to go up and look at what exact variable am I looking at here. In this case, I'm looking at the self-reported general health status 0 to 20. So that's one reason that you put in a variable label. Other reasons are that when you're searching through lists of variables in different analysis menus, it will give you the option of showing those variable labels instead of the variable name, which can be very helpful when you're searching for a variable. Okay, the next thing we have is values. And values means is similar to a variable label, except it's a label for the different values that the variable holds. So for example, a variable like ID, it would make absolutely no sense to specify values. 10001 does not have a label that's different from 10002. So it doesn't make any sense to do that for anything other than categorical variables. And so in this case, what we have in this data set are 3 categorical variables. We have their gender, their HIV status, and their borough. And if you remember from the Excel spreadsheet, each of these have numbers that correspond to a certain group. And so when you have a variable that is categorical and different numbers are actually just placeholders for a group's label, you go in here into the values label and you can put that in. So if you remember, for gender, we have 0 is males and 1s are females. So all I have to do here is type in that 0 means male, and I add that to the list. You can see it says 0 then equals male. And then I can do 1 corresponds to female, and I add that to the list. And then now it knows that 0s are 1s and 0s are males and 1s are females, so that when I do analyses, instead of showing me 0s and 1s, which I may forget what they mean, it will show me male and female, which is so much more helpful. Because these numbers don't have any meaning, there's no reason to have it showing you the numbers all the time. It makes a lot more sense if it can show you the actual placeholders for those numbers. The same thing for HIV status. We talked about 1 means HIV negative, 2 means HIV positive, and 3 means unknown. So the participant just didn't know what their HIV status was. I hit OK, and it saves those there. And then the same thing for borough. We talked about 1 being Brooklyn, 2 being Manhattan, 3 being Queens, 4 being the Bronx, and 5 being Staten Island. And I hit OK. And so now one of the most important reasons for having those is that when you go back into data view, you'll have the option of actually showing what the categories mean as opposed to the numbers corresponding to them. And like I said before, you'll also have that option when you're looking at output, when we get to output later in the semester. So if I want to see female instead of 1 or male instead of 0, and I have taken the time to assign those value labels, all I then have to do is go here to this, it's an arrow that is going into a 1 and into an A. And what this is telling you is instead of displaying the number, display me the value label. And so I click that, and now as you can see, it jumps so that now all of the variables that have value labels are displayed in terms of what the variable actually means as opposed to what the variable number is. Also, I just want to point out, I just noticed that our data set is actually not sorted correctly. It looks like probably it's sorted by HIV status right now, since all of the first group of people are all HIV negative, which became a lot easier to see once we put value labels in there, which again is another reason for doing that. It helps you to see some of these problems with the data, or well, this is not a problem, but it helps you to see more about the data. Just like in Excel, I can sort these variables by any of these things. If I want to sort by ID number, which is what I typically do like to sort by until I have a variable that I'm particularly interested in, I just right click on the variable name at the very top, and I have the option of doing sort ascending or sort descending. And so I'm going to sort ascending. That means from lowest to highest. Descending means from highest to lowest. And then as you can see in SPSS, anytime you do anything, it's going to add it to the output window. And oftentimes by default, that output window is going to pop up anytime something new is added to it. So I believe in the lab you were shown that there are also different windows in SPSS. You have your data window, which is always going to be this little red icon in the upper left-hand corner. You have your output window, which is always going to be a little blue icon in the upper left-hand corner. And then eventually we'll be working with syntax, and your syntax windows are going to have a little yellowish orange icon in the upper left-hand corner. So that's how you know the difference between them. If you're using a Windows computer like me and it groups them like it does down here in the menu bar, you'll know which one is the output, which one is the data, and which one is the syntax by the colored icon in the corner, red being data, blue being output, orangish yellow being syntax. Okay. Okay, so now the data are sorted by ID number, and you can see that we have HIV negative, HIV positive, HIV negative. We have some unknown people around here. You can see we have people from all different boroughs of Manhattan. Okay, so then now we have the value labels. The next thing is missing. Missing is not something we'll probably really deal with this semester. But just so that you know, if someone is missing something, then by default, SPSS is going to assign them a period as their value. A period in SPSS is the system value for a missing case. So for example, knowing that this person is 56, I'm just going to quickly delete that 56 and show you. SPSS replaces that with a period. Now in some cases when you're working with data, you actually have some reasons that people could be missing, and there might be multiple different reasons for that. If that's the case, I'm just going to put that 56 back there. If that's the case, then first of all, one thing you can do is assign those missing values numbers and give them a label. So for example, a lot of times in research, people will do a -999 as one of their missing values. And here they might put skipped question. If that was the case for this variable, that a -999 was what the code that we're using to indicate that someone skipped a question, I would hit OK there. And then what I could do is put here that in SPSS, we have missing values. And one of the missing values that we're using is -999. Now, the important reason for doing this is that if you don't do this, anytime you run analyses, SPSS is going to assume that that -999 is a valid number. And that -999 is going to really influence your results. So if you do have missing data and you do decide to give them specific values that correspond for different reasons for being missing, you always want to make sure that you assign those missing values in this column. If you don't, that SPSS will assume that they are valid numbers on that variable, and it will really mess up with your results. Again, we're not going to probably be really using the missing values this semester, so I'm just going to breeze through that. We can skip columns and we can skip a line. Neither of those really matters. The last thing I want to talk about is measure over here. Measure is SPSS's term for what kind of variable is it. And as you can see here, we have three different options. We have scale, which we will often call a continuous variable. We will sometimes call it an interval variable. We have ordinal, and ordinal means that the values have meaning, but that the meaning is only in their order. So for example, an ordinal variable might be an item on a scale. So if I am asked to rank something from 1 being poor to 4 being excellent, excellent is not 4 times poor. So the numbers themselves don't have meaning as mathematical numbers. The 4 is not 4 times the 1. It's not 3 more than the 1. It's simply bigger than the 1. And it's bigger, we assume it's bigger by, about a value of 1. So that's an ordinal variable where the numbers take meaning only in ordering the variable. Then nominal is what we would typically call a categorical variable. So we know for sure that our gender, HIV status, and borough variables are all nominal because we've already taken the time to assign those value labels. Anything that has a value label, you can pretty much guarantee is going to be a nominal variable. in SPSS. Now, we also have depression, general health, sleep, and drinks, which all have more of a continuous distribution than they are nominal. Particularly depression and general health, they're not nominal at all. Those numbers we assume have meaning to them. So I'm going to change depression and general health to scale. Sleep and drinks are both what we might call count variables. And count variables are a special type of continuous variable, essentially, except that they typically take on a different type of distribution. Count variables are typically skewed. I know you talked in class about skew. And count variables are typically skewed. They typically have a lot of people toward the low end saying, I did it once, I did it twice, I did it 3 times, and typically very few people out in the upper values saying, I did it 15 times, I did it 20 times. And so they're typically very skewed. However, in SPSS, in terms of the 3 different types of variables that SPSS gives us, we want to count those as scale values as well. We could probably count them as ordinal values as well. In all honesty, most of what we will be doing in SPSS, it won't care too much what you assign as the measure, and SPSS automatically assigns a measure to each variable. So you always want to check that to see if you need to change any of the ones. SPSS tries to make a guess based on the way that the variable looks, the way that the data look. And like I said, in general, it's not going to matter too much which ones you use, but I do just want to point that out because there are a few cases where it will make a difference for you. Okay, so then I do just want to quickly show you how to do a few things in SPSS just to get you just briefly familiar with and seeing the menus a little bit. I believe you have worked in SPSS in the labs already. So the first thing is that SPSS has a bunch of menus up at the top. So we have file, just like any program. We have edit, just like any program. And most programs also have view. Then we have data. And under the data, the most important things that we're going to be thinking about are the transpose and the excuse me. Actually, I'm sorry. I made a mistake here. We are probably not going to really use the data much at all. What we are going to be using a lot is the transform, particularly the compute variable and these 2 recode variables. The compute variable is what we would use to calculate something. So anything where we would do a function in Excel, we will probably use the compute menu in SPSS to do the same thing. So for example, if we had weight and height in this data set, which we don't, but let's for 1 minute just pretend that this data set also includes weight and height. We could go into this compute variable menu, and it has a few features here. So the first thing is the target variable. Target variable means what is the variable that you want to create? What do you want to call it? So in this case, if we had height and weight like we did last week, we could create a new variable called BMI for body mass index. Then we can go ahead and automatically assign type and label like what we were just doing in the variable view. So we could call the label calculated BMI from height and weight. And we could give it a type. So in this case, we're going to keep it as the numeric type, and we could hit continue. And then here, what we could do is we could pull over variables and do functions with them. So we could say age plus sleep, which absolutely makes no sense in this case. But in addition, what you'll see here is that you don't have to be pulling over variables. If you know the variables' names, you can just type them in. So if we had variables in this data set called height and weight, we could just type in height times weight. I forget what the exact calculation for BMI is. I know that it's divided by something. But just in general, the transform menu is where you will create new variables from existing variables. So for example, if we wanted to, so here's one that we could create, sleep minutes. So what we can do here is we could take the number of hours they slept, and we could change that into a variable that measures the number of minutes that they slept. So in this case, I'm going to put number of minutes slept the night before the survey. I'm going to keep it as a numeric variable and hit continue. And then I'm going to pull in the number of hours that they slept, which you can do either by highlighting it and pressing this arrow, or you can do just by double clicking on it. I'm going to do sleep. And then to create this, we know how many hours they slept and we know how many minutes are in an hour. There are 60 minutes in every hour. And so if we multiply the number of hours they slept by 60 minutes, then we'll know exactly how many minutes they slept. Just so that you know, they have over here all of the different functions that you can use. So sort of just like that little drop down that you get next to the write-in bar in Excel, this is essentially your drop down in SPSS. This has all of the different functions that you can use when you're in this compute variable menu. So if I hit OK, it's going to create this new variable for me. So like I said before, it's going to show you the output window to show you that it was done. And then if I go over in data view, what you can see is that everybody now has this new variable called sleep minutes, and they all have a value for it. And all that we did here was we took the number of hours that they slept and we multiplied it by 60 to get the number of minutes that they slept. If I hover over this, the label that we applied to it in the compute variable menu is already here for us. Okay, and then also just to show you in variable view, now we have a 10th row here because we created a new variable. The label has already been assigned to it. It was we kept it as numeric, and SPSS automatically chose to make this a variable with that can have up to 8 digits and 2 decimal places. This is typically the SPSS default when you're creating new variables in SPSS and don't specify one of those things for it. You can also see here, oddly enough, that SPSS still called this a nominal variable, even though it's quite clear that there are all kinds of different values for it. So in that case, all we have to do is just change that to scale and move on. Okay, so that was under the transform menu compute variable here. The other ones that we will probably use later in the semester when we're dealing more with categorical variables are these recoding. And that's when you really want to take one of these categorical variables or even a continuous variable and kind of break it down into smaller categories, basically, is the most common reason for using it. So if we wanted to combine anyone from Brooklyn or Queens into the same borough because they're technically on the same landmass, then we could use those recode variables menus to do that. The other big two that we're going to be using are the Analyze menu and the Graphs menu. Under the Graphs menu, we're mostly going to be going all the way down to the bottom to Legacy Dialogues, which has all our different graph options. We'll be using bar plots. We'll be using histograms. We'll be using scatter dot plots a lot. We'll be using some box plots. So that's under Graphs Legacy Dialogues is all of those different options there. And then under Analyze, we're going to be doing a lot of different things. The first thing we're going to be talking about are descriptive statistics. And the thing I want to just show you today quickly are some descriptive statistics for our variables. So earlier what we found out was how many males and females we have in the data set and what % of the data they are. If I want to gather that from SPSS, I can go to this frequencies menu and I can find our gender variable. And you can see here, by the way, what it's showing me is not the name of the variable. It's showing me the labels that I chose for that variable. Now you can turn that off. So if you right click on this list, you can choose whether you want it to display the names or the labels, and you can choose how you want it to sort these. Typically, so the default is to display the labels and to sort by the order that they appear in the if I wanted to just view the names of the variables, I can easily do that. But I think it's nice to view the variable labels most of the time. In this case, I am just going to view the variable names because it makes it a little bit easier. So I'm going to pull gender over into my list of variables that I want to get frequencies for. And I'm just going to do, so we're not going to need the statistics or the charts buttons in this case, but we will go through those in future weeks. But I'm just going to hit OK now. And what you can see is it told us we got 135 males and 114 females. This is exactly the same result that we got in Excel. Luckily, we would hope that we would get the same results regardless. And you can see that the percent of the data that are male is 54.2, and the percent of the data that are female is 45.8. I believe in Excel we had those rounded to 54 and 46, but SPSS is giving you that with a decimal point added. All of these things, including the number of decimal points that it shows, can be changed in SPSS, but I'm generally going to go ahead and use just the SPSS defaults. You can also use that frequencies menu to get some information about some of these variables. So for example, if we just want to get some information about depression and general health, we can go into the statistics menu here, and we can ask it for anything we want. So here we have quartiles. These quartiles are going to be exactly what you would expect. So it's going to be our 25th, 50th, and 75th percentiles. We can ask for a mean, a median. We could ask for the mode. We can also ask for the standard deviation, which we haven't talked a lot about yet, the minimum and the maximum. Eventually in the semester, we'll get more into skewness, in which case we could ask for a skewness statistic. So I'm just going to go ahead and click continue in this case. You can really play around with this menu and ask for a bunch of different things. If you ask for percentiles, you can specify the percentile. So just like we do in Excel, you could specify a 15th percentile, you could specify a 5th percentile, you could specify a 72nd percentile. All of those are possible. You just type in the number here and then do add. But I'm going to turn that off for now, hit continue, and then I'm going to go into charts. And what I'm going to ask it for is a histogram. The frequency table here, where you have the option right here of turning it on or off by clicking this, this is the frequency table here, where it shows you each category, the frequency, the percent, the valid percent, and the cumulative percent. In this case, these have a very big range. The depression goes from 0 to 10, general health goes from 0 to 20. This table is not going to be very helpful for us. What's going to be a lot more helpful is knowing the mean, the median, looking at the distribution in a histogram, etc. So I am going to go ahead and turn off those frequency tables and hit OK. So here what you can see is we had no missing data on either of these variables. All 249 people had valid data to be included in these analyses. So you always want to start by checking your sample size, the number that were included and the number that were missing. You may have people missing that you didn't realize, and this will tell you about that. Next, we see that the mean on depression is 5.06. The mean on self-reported general health is 9.3. So both of those are around the midpoint for these scores. We have 0 to 10 for depression, and we're getting about a 5. We have 0 to 20 for general health, and we're getting about a 9, so slightly below the midpoint of 10. Median is 5 and the median is 9. So those are very close to the mean, which is a good sign of a pretty normal distribution. The mode is 5 and the mode is 10 here. Again, that's right at the midpoint of these scales, showing that they're pretty good scales. We have a minimum of 0 and a maximum of 10. Oh. Looks like actually, so this is good that we looked at this. It looks like we're actually getting some scores on this general health status variable that are out of range. So we're getting -3 to 22 here when it's only supposed to be 0 to 20. So I'll actually have to go and look at those data and fix them before we use them again. Another reason to always do these descriptive statistics on your data. The 25th percentile is 4, the median is 5, and the 75th percentile is 6 on depression, 5.5, 9, and 13 for health status. And then we get some histograms here. So on depression score, we are seeing a relatively normal distribution. It's a pretty good bell curve, although it's a little high in the middle and a little low at the ends, but that's not too bad. And the same for self-reported general health status, even more normally distributed. But again, notice that we're going below 0 and above 20 here, which is a problem. I will need to go in and look at where the problems are in the data and go ahead and fix those before we use them again. But just some basics of the most common descriptive statistics that we'll be doing this semester in SPSS. Let me just make sure. Okay, we have no questions. So I am going to go ahead and end for today. I will upload the Excel data and the SPSS data so that you can play with them if you want to, although I did not create any exercises for you to do. Always remember that you can email me, especially let me know whether or not the resolution was any better this week, whether you could see things and if there were any problems hearing or anything like that. We will not have a tutorial next week because you're not having a Monday class. So I won't be doing the office hours on Tuesday or the tutorial on Thursday next week. However, the following week will be the first time when I will do the online office hours on Tuesday. We'll be using Blackboard Collaborate for that. So you can log in and right under course information, there will be a link that you can click on. But you do need to make sure that you email me sometime before Tuesday night to let me know if you do want to meet during that time, because I will not be logging into Blackboard Collaborate unless I have appointments set up for online office hours. So definitely 5 o'clock would be the absolute latest that you could email me on Tuesday to let me know that you would like a time to meet. Like I said, if I don't hear from anybody, I won't be on. And it's also possible, if you email me too late, that people will have already booked up the times. So the times available will be from 6:30 to 8:30. If you are really hard up and you can't make it for those times, we could try to set up another time. It'll really depend on the week and what my schedule is like. But in general, please always make sure to email me if you would like an appointment for those online office hours during that time. Again, skipping next week, it will start the following week. Thank you all and have a good night.